Hello and welcome to Coding from the Car, and today I want to talk about what I wasted my week learning. For some, this might seem like a highly specialized topic. Who the hell uses Excel for coding? Why not just use SQL, much easier to program around? Well, like a monkey with a stick, I beat around the bush with all the effort my monkey brain could muster, and I've come to this conclusion. Unless you've got to deal with Excel like I do at my daily, just use Excel. Or even XML would be a better option. I'm just saying, Excel interop is not that user-friendly, especially if you're learning it in a week. But if you must know, first you want to be using, this is a long one, Microsoft.office.interop.excel. Oh wait, that's right, you can't use this like a normal reference. And the NuGet doesn't work like it's supposed to. So you gotta search for the reference through the comms section under the Projects tab. Now, just set that long bit of text equal to using Excel so our life is a lot easier, and we're a minute into this video and we haven't even coded yet. Jesus Christ. Also make sure you are using System.io so we can muck about with the files and we can code. Next, declare a static string variable. And in the quotations, name the file whatever suits your needs and add extension .xlsx. The file will be created programmatically. The file's root path is determined by Excel, meaning by default it will save in the Documents folder. Next, we need to create a faux file to check to see if Excel file exists. There's probably a better way to do this, but f it. This is my video, I do what I want. Next, we need a variable to reference the Excel application. This can be seen here. Next, you want to reference both the workbook and the worksheet here. Lastly, for the globals, set up two int variables. These can be used to get the range of cells used in the worksheet. Now in the main function, we need to instantiate the application variable. And before we go any further, we need to deal with the file creation issue. For this, we need to create a function with a simple if statement in it. Basically, if the file doesn't exist, we need to create it. Remember the faux file that we are using to check to see if the Excel file exists? Here's the reason. If I say file.exist Excel file, then the program will look for it in the debug folder, while Excel looks for files in the documents folder. And I recently got into GitHub, and well, my excuse is it was much easier to work on multiple computers this way, so... Also, even though it's in the repository, GitHub doesn't recognize the empty file. I didn't realize this at the time, but hey, it works, so that means it's a feature, not a bug. Use file.create to make the faux file and move on. When creating Excel files, there has to be some formatting involved, meaning file.create won't work for this. We need an Excel application to create a new workbook for us. And you do that by opening a new workbook and saving it to a destination. We've done that here. Now we can call the file creation function in the main function. Now with the file created, we can open it and set it equal to the workbook variable we created. Next, we can access our worksheet by setting it equal to the worksheet variable. When you do this, it requires an int parameter. Excel workbooks can have multiple sheets. We only have one, so hence 1. Next, we need to set the two int variables we set up earlier equal to the amount of used rows and used columns respectively. This probably isn't the best way to do some of the things we're going to do. You'll see when we start searching the Excel file. Explore the documentation a bit more than I did, or at least longer than an afternoon. And if there's anything that I've learned from my weekly projects, it's that it's hard to understand something fully in a week, so... Well, anyways, now at the end of the main function, we can save the workbook, close the workbook, and quit Excel. All three of these things are important because even though Excel isn't viewable, there is still a background process running, and if you run the app enough times without closing Excel, your computer will start sounding like a fighter jet gearing up for takeoff. Add a console write line to console read line so the window doesn't disappear, and we can get to the meat of the project. Let's start by adding the columns to our Excel file. Create a static void function down below. Next, add a console write line to let the user, you, know where the header is going to be written. I've done that here using the variable we set up earlier. Create a call to the function in the main function and run the app. As you can see, our int variable returned 1 even though we haven't added anything to Excel yet. So we have to account for that when adding to our cells because cells 1, 1 will always look filled. For that, we need an if-else statement looking to see if there is anything in cell 1, 1 or not. If there isn't, we can add our console read line to that cell. Grab the worksheet variable and use the cells property. The cells property takes a matrix. This determines the cell we are working in. Here, cell 1, 1. Then use the value property to get or set our cell's value. In the else statement, we need to account for everything except for cell 1, 1. This is where our int variable for the columns comes in. Since we are adding headers to the row, we will always be using 1. And with the cell 1, 1 filled, we need to add information to the number of used cells plus 1. For example, if we have 3 headers, we have 3 used columns. Our used column int will return 3, so plus 1 will be an empty column. So we do the same as above, except instead of a 1 in the column section, we used our used column int variable plus 1. Now run the program, and each time it is ran, it will add a column to your sheet. Here I added name, date, occupation, and salary. For a little extra spice, you could add an if-else to a while loop and not have to run the program 4 times, but I didn't do that. Have fun. If you know how to write columns, you can kind of guess how this is going to work. Start by creating a function and adding a console write line so you know which function is active. Then create a bool variable, then 2 int variables, each set equal to 1, then create a while loop with the bool set as the property checking for a false value. In the while loop, add a blank string variable, then an if statement. So far it should look like this. In the if statement, we need to edit the cell as long as the cell is underneath the column header. To do this, we take one of our ints and compare it to how many used columns we have. If it is less than or equal to the amount of used columns, then we know that we are under a header. Next, we need to know which header we will be adding to. We can do this by adding a console write line that states the value of cell 1 and your int variable. This is the same variable used in the if statement. Next, set your empty string to a console.readline. Then start a nested if statement, checking to see if your string is not set equal to a keyword of your choosing. Make sure you use 2 upper or 2 lower so you don't have to worry about case sensitivity. In this nested if statement is where we will do the work. Finding the cell you need to be editing is the same as finding the empty column like before. If we have 6 used rows, then we need to edit the 7th, so used rows plus 1. The column value, on the other hand, needs to be incremented through with a second int, meaning if you have 4 columns, then you need to add information to column 1, 2, 3, and 4. Do this with both int variables we declared earlier. Set the cell value equal to the string variable, then we can manage incrementation and breaking the while loop. For now, you should have this. After the nested if, we need to add an else statement. In this, we need to break the loop if your console read line is set to your keyword. Do this by setting your bool to true. After the else, increment the int you are using to compare to your column count. Then underneath the first if statement, add an else where you reset your first int to 1 and increment the other. If you haven't caught on yet, the first int, here it's j, loops through the columns, and the second int, here I, increments through the rows. Lastly, add a call to the main function. Now you can run your program and it should read off the header and ask for the info you want to add. And if you put in your keyword that you set up, here break, it will stop the app. Boom, info was added to Excel. Having to search the Excel file programmatically is probably the main reason Excel isn't really feasible as a database. The code becomes a bit of a mess, but either way, Start by creating a new function down below to hold this cluster that is this code. Console.WriteLine something so we know which function is active. Create a string instead of equal to console read line. This string will be the query posed to Excel. Now we have to discuss why this is a mess. I spent an afternoon researching this and was not able to find an easy way to query Excel, meaning that it is already far more complicated than SQL, because any novice can figure out how to query SQL in like 10 minutes. But with Excel interop, there isn't really an easy to find way. And if it isn't as easy as SQL, then why use it over SQL unless the Excel interface is really your thing? That being said, I'm not going to go over every line of code for this because it's just not good. The basic gist is that you need two for loop over all the used rows and the used columns to essentially read every cell until you find your query term. The cell's property value is kind of like using the var variable declaration. When you grab information from Excel, it decides what variable it's going to be. So if you grab words, then it will return as a string, numbers as an int, etc. This poses a problem because a null value can't be converted to a string, and numbers can't be compared to a string without being parsed as one. So in total, you need two for loops and two if statements all nested inside each other, and that's excluding the for loop I added at the end to display the entire row. Imagine if you had 3,000 rows of data and was trying to search the file. Either way, if you must know how to do it, here's the whole function. And if you run it, it does work, just, I don't know, man, do some more research than I did, and let me know if you have a better way. I was also going to show how to display the entire worksheet, but this video is already 12 minutes long, and all you gotta do is just loop through all the cells. There, I just saved you 3 minutes of me talking about it. Anyways, I promised myself to upload at least a video a week, and this atrocity is what I wasted my week doing. If this video helped in the least bit, leave a like, comment, and subscribe. Please don't use Excel for a database unless you have to. Okay, bye.